Hi, my name is Larry Bolan, and this is video documentation of my ECT 499 project. My project was rehabilitation of this and two identical process control systems which are used for controls classes here at Purdue College of Technology and other Purdue College of Technology statewide locations. Here at New Albany we have three of these systems. I'll only be showing one of them, but the other two units are exactly identical with the exception that I do not have a cart to be mounted on right now. I'll begin by describing the various hydraulic water control components on the system, and then I will demonstrate the electrical functionality of the system. Okay, to begin, their inputs to the system in terms of water and compressed air are a cold water hookup. There. We have compressed air, which is either the proportioning valve. We have a hot water input for hot water, and then we have a drain. When fully hooked up, the system can be used to either control temperature of the water in this tank. It can be used to control the fluid level of the water in this tank, or it can be used to do both at the same time for an advanced control scenario. This water is then metered in the system through either a proportioning valve, which is used for the cold water only, or through two solenoids, which one for the hot and one for the cold. Those two pipes are then teed together into fluid input, which then goes past a flow meter here. From here, the water goes through this hose, which goes around, and ends up at this connector here, which can then be connected to the bottom of the tank, depending on where you want the water to flow. From here, the water then drains into this pump, which is very speed and has a sensor for speed detection, and then flows to solenoid, mix and feed to the top of the tank. I'll turn the other solenoid can be flown to the drain hookup over here. These components allow for the various types of control. The system can be manual controls using these switches up here. This can be used to bypass the control by using external devices connected to these two connectors back here. For an actual experiment, one would first use the controls to calibrate the to measure those input sensor variables at nights, and then using that information, they would then switch control to say a PLC or a microcontroller to actual type. For instance, seeing the controls for a 3-position control, or using the drain valves for control, or by using just single solenoid for 3-position control. Or, third option, using the pump and or the proportioning valve for a very fine setup. To begin with the electrical explanation, when you first go to use the system, one needs to check their circuit breaker. That since this thing uses tap water, which we all breaker is in working condition, does not possibly have a problem in case of a water short. So when you first turn it on, use the test button to test it. We can see that's good. So I'll go ahead and clear it and turn it back on. When you turn it on, there is a red light at the top of the controls up here. Light up to indicate that it's operating. The camera isn't really showing. Next, you want to use these controls select what inputs are neutral, which ones are being controlled manually, and which ones are being controlled by the cable inputs. Now, there's a word of caution for the pump control. You always want to set the speed control up here to, as per what this chart shows, to, which means knob control, or to cable means an analog on these controls. But you don't want to leave it neutral. And the reason is because when you leave it neutral and then turn it on, it goes to full power, which is not necessarily what you want when you first in the morning. Make sure that when you first turn it on, that you set the speed to either cable, which strangely pump on default 0, so you see the in the fact motor is stalled, as you can set to, or likewise set to manual and just use the knob as you to the gear 2, which I will demonstrate here. Right now I have the knob set off. I'm going to turn to 1. You can hear it rotating. If you look, you can see it rotating. I'm going to 2, and I'll turn all the way up to 3. You can hear it going. And as you heard during my test earlier to show what happens when it's set to blast, this pump is a lot faster. I'm just not at full speed since I don't have water actually hooked up. So anyway, turn it off, then turn the speed off. And since these speeds that has that positions here, the bell position is no man's land, always turn it off before changing the speed setting. Always, always, always. That's the pump, which is one of 2 variable controls we have on the system. The other one is proportional. Now the only is the control switch, which is here, which if I turn it to manual, nothing happens that you can hear. Because this system is, that's why there's a compressed cup. Compressed air in this lab, I cannot actually show how that works. However, for that system is basically really control. All the switch does is determine if this valve will do anything at all. All the rest of the controls are all electro-pneumatic, which is not as on the manual setup. Okay, last are 4 noids I will the usage. We have noise which are direct cold water into the system, and the mix and noise used to direct water either back into the tank or to the drain. Whatever you're running the pump, you want to make sure at least one or on for the mix. If you have neither, the pump will not actually go anywhere. So the hot, which manually, you should be able to hear. On again. You can kind of hear it as a bit of a knocking noise. It's cold, which you can definitely hear that one. Again. Our mix solenoid, which you can hear. And then the drain solenoid. And that is all the electrical outputs that can be manually controlled. Last, there are some connections which I will briefly show. We have our main line voltage connections back here. We also have some connections over in here. We have some touch points here, various points for the. These are proportioning valve control, and these are for the RTD, the temperature, which is the sensing device used to measure tank temperature. Also have wiring connections up here, which for most intents and purposes will not be needed, as all connections for be done up in here. Something else to note is that the wiring here has these yellow wires for cable restraints. These yellow wires do not actually carry current. They are not for signal. They are just there to restrain the wires in lieu of zip ties. And finally, we have some solid-state relays down here which are used to control solenoids. This concludes my video on the usage of this process control setup. The presentation by Mike Jacob is more thorough in terms of actual operation of the unit and where all the plumbing works, and includes all the data on all the sensors and expected voltage ranges. Thank you for viewing this.